Hi, in this tutorial we're going to take one of our pre-trained models and we are going to visual it. That means that we are going to see and understand what the network sees. So actually we are going to take a test image, and after training the model, these are, for example, two of the neurons. The white area presents the learning area. This is, for example, a full layer of 64 neurons, and this is another layer. We are going to focus on the white areas that presents what the filter does, what the filter are trying to predict. So let's start with the coding. So we are going to use our previous model from the previous lessons. We are going to choose one of the pre-trained models. For example, let's choose the transfer learning pre-trained model. So first of all, we are going to import some libraries and some functions and objects, like the function load model that enable us to load our previous model. We are going to resize our image, our test image, to the size of the model image for the input model. In our model it's 200 by 200. So this is the model that we are going to use. We save it earlier as this name, my learning model.h5. We are going to add the full path in order to load it. Now we are going to use the function load model to import the model, to load the model, and we will print the summary. So you can see this is the input image. These are all the layers. It's a VGG16, but it was transformed to our 10 classes model. This is what we have done previously. Now let's get an object. We call it all layer, and we are going to load inside all the model layers. Let's print it. Basically it's a list, and each item in the list would be a layer in our model. Let's see how many layers we have. Okay, basically we have 21 layers. Now we are going to loop inside these layers and just print the name of the layer, and enumerated number, and then we are going to use it in our next phase. Okay, for each layer we have a number and its name. Now basically we are going to focus on our convolutional layers, and first of all let's look at the filters. Let's choose layer number 1, which called block_conv1, and let's show one of the filters, and next we are going to show all the filters. So this function getWeights returns two return arguments. The first is the filters and the next one is the biases. Let's focus on the filters. Let's print the shape of the filter, the filters one. and we can see it's a 3 by 3 by 3, and basically that means we have 64 layers that are composed of 3 by 3 filter, and the third 3 is the channels, since we have 3 channels: red, blue and green, RGB. So let's, for example, show filter number 20. We saw earlier that we have 64 filters in layer number 1. Let's show filter number 20. We are going to use the function IMShow in the plotlib. This is the syntax in order to show this filter. And let's run it. Okay, this is filter number 20. Now let's continue for the next step. Let's move to layer number 2. And now we will do some adjustments in the code. Once again, to show inside filter 2, which represents all the filters inside layer 2, and we would like once again to show filter number 20 in layer number 2. Let's continue and move on to layer number 4. The same process, and now you can see filter number 20 on layer number 4. This is the one. Let's move ahead to a more advanced display, and we would like to show the whole 64 filters inside layer number 1. That means we are going to do a loop inside all layer number 1, and we are going to show all the filters, all these 64 filters inside layer number 1. So this is the syntax in order to achieve this. We are going to build a matrix 8 by 8 and run a for loop and show in each placeholder the relevant filter between 0 and 64. So basically you can see that in each rows and calls we are going to subplot the relevant filter. The set x ticks and set y ticks turn off the axis, and the rest of the code is showing the filters on the screen. Okay, let's run it. So first of all, we are going to show our 3 filters, and this is the outcome. We are displaying all the 64 filters of layer number 1. So let's move ahead, and now we would like to visualize the result after the training for each layer. We are going to choose layer number 1, layer number 2, and layer number 4. This is basically the three first convolutional layers in our model. So let's continue. I will save it as a new file just for your convenience to follow this tutorial. Of course, all the code will be uploaded to my GitHub. Okay, so now let's plot the outcome after the training of these 3 layers. So in order to achieve that, we are going to create a new model, a shortened model, a model that will contain only these 3 layers. So we are creating a list of 3 numbers, 1, 2, and 4. And now we are going to loop inside this layer, because we are going to show for each of these 3 layers the same outcome, the same results of the neurons. So first of all, let's build this new model. We are going to create, using the append function, these 3 layers as a new model. The model will have the same input as our original model, and the output basically will be our new shortened model. So the whole result will be this new model that contains 3 of the layers with the same input of 200 by 200 images. So we are going to import the model object, and we are going to create a new variable, model short, and using the model object, we are going to send it 2 arguments. The input will be our original input, and the output will be what we just have created with the previous loop. So after printing the summary, you can see that we have 3 layers, and of course there is one input layer. Now let's choose an image. We're going to choose this image. Let's copy the full path of this image, because we are going to load it. We are going to use the load img function in order to load this image. Of course, our target size would be the same target size of our model. We need the image class from Keras preprocessing, because we need to convert our loaded image to NumPy array. So we are going to use image to array. Then we are going to divide it to 255, because we need to normalize it for our model. The same as we did earlier in the prediction process. We have a syntax error. Okay, let's fix it and run it again. Let's print the shape, sorry. So the shape is okay, 200 by 200 with 3 channels. Now since our model works with a batch of images, we have to use the expand dims, same as we did in our previous testing model. So we use this function expands dim. So now you can see that the shape is 1 by 200, 203, because it's like a batch with 1 image inside. So now we are run the predict function. May I remind you that this is a shortened model, so the prediction is just only to run it through our model weights. And afterwards we are going to show the results, which is basically very amazing, and we will see what we are going to visualize the CNN model. Okay, let's get from our predict function from the variable feature output, we are going to get the result of layer number 1. It will be stored in feature 1 layer. Let's print the shape, and this will help us to understand how many filters exist in filter number 1. So we can see that it has 64 filters. That means we have 64 neurons. That means we have 64 outcomes of the first layer. Once again, let's see one of the neurons. Let's choose neuron number 20. And we will focus on showing this filter. And next we are going to show the whole layer, the whole neurons inside layer number 1. So now we are going to show only filter number 20, so only the outcome of filter number 20. This is neuron number 20. You can see all the white lines, white dots. This is the area that the filter is looking for inside the image. Now let's show layer number 2, and we are going to show the same neurons. Neuron number 20, it's not the same neuron, so it's neuron number 20 inside layer number 2. Okay, this is in layer number 1, and this is layer number 20 in layer number 2. You can see what this neuron is looking for inside the image, what will trigger it, what will activate it in order to understand that this is a monkey image. So now let's plot the whole 64 neurons, the filters, so basically it's the outcome of the filters. So we will create a matrix of 8 by 8, and we will try in one code to show the 64 filters, 64 neurons of the first layer, the second layer, and the fourth layer. So now please follow this code. We are going to loop inside each of the feature output. And we are going to retrieve the neuron, and we are going to present it. In each title we are going to show the name, or basically the number of the layer, since we will have three plot diagrams. So in the title we have layer number 1, 2, and 4, and inside each layer we are going to loop by rows and columns and display the outcome, display the neuron after the training. This IMShow function will display the relevant neuron. We are using the FTR, which is running inside the feature output, and the I-1 represent the number of the neuron. Okay, let's run it. Okay, we have a syntax error. Let's fix it and run it again. This is the previous outcome, and now this is the whole neurons of layer number 1. Very nice. This is focus on this face, this is focus around the face because this is the white area, and you can see in each of the neuron what trigger, what activate the monkey face. This is layer number 2. You understand which neurons are the relevant neuron. And now layer number 4. Hope you enjoyed this tutorial. Thank you very much. You are most welcome to subscribe for more videos. Bye bye.